Okay, first of all, we have a train which is travelling at a constant speed. And we know that if a train is, or anything is travelling at constant speed, we can just use the usual relationship between speed, distance, and time. Now, in this case, we're given the distance. The speed is 30 meters per second, which means that we're trying to work out the time, and the time is equal to the distance divided by the speed. So the distance in this case is 12 kilometers, well, that's 12,000 meters. Remember, the units must correspond. We're dividing that by a speed of 30 meters per second, which means that the time taken is 12,000 divided by 30. Well, that's just 400 seconds. So the time taken for that first stage of the journey, or sorry, for the whole journey, is going to be 400 seconds. What it now tells us is that between A and D there are two other points. So we've got A, and then the train goes from A to B, B to C, and C to D. And what's happening is that you've got 2,000 meters between A and B, you've got 6,000 meters between B and C, and you've got 4,000 meters between C and D. And on one day there's a speed restriction between B and C. So what happens is that the train decelerates between A and B, constant speed then between B and C, and then it accelerates until it gets back to D. So first of all, we want the time taken to go from A to B. Now what's happening between A and B is we have a deceleration, and in fact it's a constant deceleration, so we can use the constant acceleration formulae. So let's write down all the SUVAT formulae. Now in this case we are told that the initial velocity is 30, so we're talking about from A to B, so we know that u is equal to 30. We know that the final velocity at B, that's going to be 10. We are given the distance between A and B, so that is s, which is 2,000, and we are asked to find t. And what we need then is the equation that connects u, v, s and t, which looks like this. S equals half t multiplied by u plus v. So let's start putting in the information. So we know that 2,000 is equal to half t, t is what we don't know, and then u plus v is going to be 30 plus 10. So 2,000 is equal to half t multiplied by 40, and if I just do half of 40 is 20, I've got 2,000 is equal to 20t, which gives me the fact that t is going to be 2,000 divided by 20, so t is going to be 100 seconds. So that gives me the answer there to part 2. Right, part 3 says the acceleration over the distance CD. Okay, so CD is this part of the journey, so we know that u for CD is going to be 10, and we know that v, because that's what the speed that it reaches when it gets to D, v is equal to 30. We're told that the acceleration is uniform, and we know the distance between C and D is 4,000, so that's S is equal to 4,000 meters. And we are asked to find A in this case, and the equation that connects U, V, S and A is V squared equals U squared plus 2AS. Now if we put in the information, I've got 30 squared is equal to 10 squared plus 2a, and in this case s is 4,000. So 30 squared, well that's 900, is equal to 100 plus 2 times 4,000, well that's 8,000a. I'm going to subtract 100, so I've got 800 is equal to 8,000a, and if we divide both sides by 8,000, that gives me that a is 0.1 meters per second squared. Okay, for part 4 we need to work out the time for all of the distance from A to D, and we have already worked out over here between A and B. We know that the journey took 100 seconds. I'm going to have a look now at B to C. Now for B to C, to work out the time between B and C, we are told that the train travels at uniform velocity. Okay, and if it's travelling at uniform velocity and we want to work out the time, then the time is just going to be the distance divided by the speed. Now in this case, the distance between B and C is 6,000 meters, and you are told that it's travelling at a constant 10 meters per second, so the speed is 10, which means that between B and C, the time taken is 600 seconds. Right, we now need to work out the time to go from C to D. Well, if we look at C to D, we've got all of this information already. So I'm going to use U is 10, V is 30, S is 4,000, and I want to work out T. So again, I'm going to use S equals half T times U plus V. In this case, S is 4,000, T is what I'm looking for, so that's half T. 10 plus 30 is 40, which means that 4,000 is equal to 20T. So T is going to be 4,000 divided by 20, which comes out as 200 seconds. So what we've now got is the journey time for all three parts. So if we look, we've got A, B, the time was 100 seconds. From B to C, the time up here is 600 seconds. From C to D, the time is 200 seconds. So the time for the whole journey then comes out as 900 seconds. Now, we worked out in the first part that without the speed restriction in the middle, the journey time was this 400 seconds, which means that the extra time that has now been taken is going to be 900, take away 400, which is going to be 500 seconds. So that's how much longer the journey now takes with the speed restriction in.